When you look at a map of India, you see 28 states and 8 union territories. But those political lines fade away when you look at the raw topography. Beneath the borders lies a massive, dynamic geographic engine, defined by towering extremes in the north that drop abruptly into vast, flat expanses in the center. Where a person lives within this physical mosaic determines the local climate, the soil they walk on, and the specific resources their community relies upon. It creates a topographical domino effect, where every physical region reacts to the one above it. We can trace this chain of cause and effect by traveling from the highest freezing elevations in the north, down through the plains, deserts, and plateaus, all the way to the tropical oceans in the south. On this subcontinent, local life is built directly on top of these physical divisions. To see how that interaction works, we have to start at the highest point and follow the water. The journey begins at the northern mountains. The Himalayas are a massive tectonic wall. They act as a continental shield, blocking wet southwest monsoon winds from escaping north and forcing heavy rain, while preventing freezing Central Asian winds from sweeping south. Because of their extreme altitude, these peaks operate as a colossal water tower. The freezing temperatures lock away millions of tons of fresh water as permanent snow and ice, isolated high above the warm valleys. As that ice slowly melts, it gives birth to perennial rivers, waterways that flow year-round. At the Gangotri Glacier, the melting ice forms the Bhagirathi River, which eventually merges to become the Ganga, carrying fresh water steadily downward. These harsh frozen mountain extremes provide the steady water supply that sustains hundreds of millions of people downstream. As those mountain rivers rush southward, they hit flat land and slow down. The water spreads out, depositing millions of tons of rich, fine sediment called alluvium onto the ground. Over millennia, this continuous deposition created the Northern Plains, a vast, distinctly flat expanse stretching between the Himalayas and the southern plateaus, coated in hyper-fertile soil. The physical layout here creates a specific economic result. The combination of flat terrain, a year-round supply of snow-fed water, and deep, nutrient-rich soil allows for massive cultivation of crops like rice and wheat. Because the northern plains can produce so much food, they support some of the highest population densities on Earth and host many of India's largest cities. To the west, the variables change. In the Thar Desert, rainfall drops to just 10 to 50 centimeters a year. The lush plains disappear, giving way to an arid landscape of shifting sand dunes and rocky outcrops. Life here adapts to the dry heat and scarce water. Standard farming is replaced by drought-resistant shrubs, and human survival shifts toward nomadic herding and trade. Even the architecture reflects the terrain, using local sandstone to withstand the harsh desert environment. Without a perennial river supply, civilization reorganizes entirely around water conservation and mobility. South of the plains lies the Peninsular Plateau. Unlike the plains, a plateau is an elevated landmass with a flat top and rugged edges. This ancient geological shield, split into the Central Highlands and Deccan Plateau, is covered in red and black soils, perfect for growing cotton. The rivers here, like the Godavari and the Kaveri, have no melting glaciers to feed them. They are entirely rain-fed and seasonal. Because of the hard, ancient stone of the plateau, these rivers carve deep, dramatic rocky gorges rather than wide floodplains. This rugged geology drives a regional economy built on mineral wealth, stone quarrying, and agriculture timed to the seasonal rains. At the plateau's edges, the Ghats, the land drops down to the coastal plains. These are narrow strips of flat ground sandwiched between the hills and the sea. Where the plateau's rivers finally meet the ocean, they form wide deltas. This flat terrain naturally accommodates deep water ports, turning the coastline into hubs for international maritime trade and fishing. Far out in the oceans, we find the final division, the island groups. Lakshadweep in the Arabian Sea and the Andaman and Nicobar chains in the Bay of Bengal are isolated, tropical environments detached from the mainland. These islands extend India's exclusive economic zone, allowing the nation to project its security and protect vital shipping routes far into international waters. Living on these geographic edges shifts a community's focus. Instead of farming the inland plains, these populations look outward toward global navigation and trade. Pulling back, we can see the entire subcontinent as an interconnected system. High-altitude snow feeds the plains, arid deserts force adaptation, rugged plateaus divide the coasts, and oceans surround the islands. This intense physical diversity creates opportunities, like varied agriculture and strategic trade, but it also brings localized challenges, from glacial melting in the north to seasonal droughts in the south. Political borders represent the human organization of the land, but they sit atop a much older system of interconnected physical zones. These 6 physical divisions explain why Indian culture, economy, and resources are so varied. This geographical diversity is the actual architecture that supports the entire nation.